Good evening, everybody. So, in today's lecture, we are discussing Unit 3. Unit 3 consists of two parts. The first one is pipe flow. The second one is boundary layer. In the first part, in the pipe flow, we have four major topics. The major topics are: what are the losses? Just before losses, Reynolds experiment. That is the first part, first question. Reynolds experiment and classification of flow based on Reynolds number. This is first question. The second question is, what are the energy losses in pipe flow? Then derivation of Darcy-Weisbach equation. That is second question. The third question is hydraulic gradient line and energy gradient line. And the last part is pipes joined in series, pipes connected in parallel, and branch pipes, and then pipe network. So in these cases, how we solve a problem? So these are the four questions that we have in part 1, that is called as pipe flow. And most important things here, Reynolds experiment is a theory question. Darcy-Weisbach equation is a derivation. Then what are the energy losses and enumerate those energy losses is a theory question. Then next thing is distinguish between hydraulic gradient line and total energy line and draw that for a particular problem. That is again a theory question. Then last point is how the pipe, what do we mean by pipes in series, pipes in parallel, write a short notes on branched pipe, explain pipe network. This is the theory part. The problems part is how to calculate the energy losses. That is first question. How to draw the hydraulic gradient line and energy gradient line. That is the second question. And third question is how to solve the problems related to when pipes are joined in series and when pipes are joined in parallel. So this is the overall picture of the entire the part 1 of unit 3, which we call it as pipe flow. With that, I will take you into the topic today. We have unit 3, pipe flow and boundary layer. So this is part 1 and this is part 2. So in part 1, we have Reynolds experiment, and this Reynolds experiment purpose is to classify whether flow is laminar or turbulent. The second one is what are the energy losses in pipe flow, and derive Darcy Wishback equation. Third one is explain what is hydraulic gradient line and total energy line. And fourth one is pipes in series, parallel, branched pipes, and pipe networks. So these are the various topics that we have. Let us straight away go into first. What is the salient points of pipe flow? When we call a flow is a pipe flow. Flow means actually pipe flow means flow through a closed conduit. Close. You have seen the pipes also flow through a closed. This closed conduit is generally circular under pressure. Kindly remember when the flow through a closed conduit is under pressure, then only this is called as pipe flow. And at the same time here, the pipe is running full. Only when the pipe is running full, we call it as pipe flow. Kindly remember, these are the two things. Flow in a closed conduit under pressure. This is one. Second one is the pipe is always running full. If suppose water is flowing only up to the half. Suppose if you take it, this is the pipe, right? In this pipe, if I take water is full of this pipe and then flowing, then we call it as pipe flow. Suppose if water is flowing up to here, then here this is air, this is water, then this is not pipe flow. This is not pipe flow. Kindly remember, pipe flow means actually here this is completely, absolutely, it is full of basically the fluid, full of water. Pipe is completely running. This is called as pipe flow. It is what the water flowing in this or any liquid that is flowing through this is under pressure, whereas here it is not under pressure because air pressure is there, atmospheric pressure is there here. So when it is under pressure, then only we called it as pipe flow. Then second point is when pipe, if this is the first point, what is the second point here? So naturally, when a flow is taking, for example, this I call it as a pipe. Now flow is taking place through this pipe. When flow is taking place through this pipe, right? When the fluid is flowing like this, there is a resistance at the boundary. At the boundary, there is resistance, and this resistance is called as the shear resistance. That means the flow through the pipe is subjected to resistance, and this resistance is called as shear resistance. Why shear resistance? Because the shear resistance is due to the here the flow is taking place with some velocity, whereas the boundary is at zero velocity. Because of this, there is a resistance, and again between the fluid particles and the boundary, the resistance is there. Why this resistance is there? The shear resistance is mainly due to the viscosity of the fluid. Because of the viscosity of the fluid, the shear resistance will be there. So this is another point that we should remember. So because of the viscosity, then what happens? So because of this resistance, it may be this shear resistance, then what happens is a certain amount of energy is lost in overcoming this resistance. So whatever the flow energy is there, it has to spend certain energy in order to overcome this resistance. So energy is lost in overcoming this resistance. So now our the how much energy it is being consumed, the energy lost or the energy loss or energy consumed in overcoming this resistance depends on whether the flow is whether the flow is laminar or turbulent. This is the first thing. So it depends on the flow, the amount of resistance. What is the magnitude of that resistance? It depends on the whether the flow is laminar or turbulent. Then in case of pipe flow, right? Generally, we find whether the flow is laminar or turbulent by using Reynolds number. We use Reynolds number to classify whether the flow is laminar or turbulent. What is Reynolds number? Reynolds number is equal to, it is the ratio of inertia force by viscous force. Inertia force to viscous force. And what is inertia force? Inertia force is equal to mass into acceleration. So then mass is equal to how much? Normally mass is equal to rho into volume. This is rho L cube is the dimension. Acceleration is equal to, it is LT minus 2. So if I take it one more L into it, rho L square into LT minus 1 whole square. So it is rho L square V square. Then what is viscous force? Viscous force is equal to shear stress into area. Shear stress is what? Mu into, basically it is V by Y into L square. So this is nothing but mu into V into, basically, then it is L. So now if I take it the ratio, Reynolds number is equal to inertia force by viscous force. So it is rho L square V square by mu V L. So if I cancel it, then naturally it is rho V L by mu. So this is the Re is equal to rho V L by mu. So this is the important thing. Then actually again you should remember that what is rho actually here? Rho is the mass density. V is equal to the average velocity. L is equal to characteristic length. For pipe flow, L is equal to the diameter of pipe, which is equal to D. Then again mu is equal to dynamic viscosity. So therefore, Re is equal to, it is rho V D by mu. This is what we should remember. Or this is also called as Re is equal to V into d by nu, where where nu is equal to mu by rho, which is equal to nu is equal to kinematic viscosity. And we know that already kinematic viscosity is equal to mu by rho. So any of these equations you can use for determining the Reynolds number. So if you want to determine the Reynolds number in a problem, we can use this equation. Re is equal to rho Vd by mu, or basically Vd by nu. So these equations you can use it to find out what is the Reynolds number. Then you can ask me, what is the need to find the Reynolds number? The need to find the Reynolds number is, so if the Reynolds number is less than 2000, we classify the pipe flow as laminar flow. It is laminar flow in pipes. And if the Reynolds number is from 2000 to 4000, we call it as transition flow. Transition. Then if Reynolds number is greater than 4000, we call this as turbulent flow in pipes. So now to classify whether the flow is laminar or turbulent, we will use this equation and then find out basically what is the type of flow. Once you find the types of flow based on it is whether it is a laminar flow, then naturally the equation set of equations are different. If it is turbulent flow, the set of equations are different. Using that, we will go into the next topic. But actually, before arriving into it, Reynolds has conducted an experiment. What is that Reynolds experiment? What is that Reynolds experiment? Reynolds experiment is very, very simple. Actually, what Reynolds has taken is he has taken a tank. This is a tank, right? And in this tank, he maintained the head as constant. So that means the head is maintained as always constant. That means how to maintain the head as constant? He has put a basically an input supply here, and by regulating the valve here, always the water level is maintained constant. So the first point here you should remember is a constant head tank. Constant head water tank. The water head is maintained as constant. Then he has taken a very, very small tank actually, with a steel tube. This is again a steel tube, having at the end actually it is having a nozzle like. So a small tank he has taken, and in this small tank he has taken actually, right, liquid called as potassium permanganate or potassium dichromate. Why these two liquids? Now if you see these liquids, the liquids are basically their color is purple color, strong purple color. You can see the color of them, right? That is number one. And second thing is the specific weight is same as water. This is the second. So he has taken a liquid having the specific weight same as water, but a strong color. So that is what a color dye. We call this as a color dye. And what is that color dye is this actually. he filled in the tank. Now what he has done, he has put actually a glass tube. This is all a glass tube. And here for this glass tube, this entry part is bell mouth entry. So remember, this is a bell mouth entry, and this is the glass tube. Now here we have a regulating wall, we have here, and this is general pipe. So this is the setup. What is the setup? Constant head water tank is one setup, right? This is the inflow into the tank. Then we have actually a small tank, a small tank we have here, and this small tank consists of a color dye, and this color dye is generally potassium permanganate or potassium dichromate, which is of very strong color, having the same specific weight as water. That is the next. Then now this is injecting, basically this nozzle is injecting the dye into a glass tube, and this glass tube entry is how this entry is a bell mouth entry, so that actually this nose, the whatever the jet, the potassium permanganate jet, it enters into the glass tube. Then actually initially the velocity is very low. First condition is the velocity of flow. The velocity of flow is very less. How I maintain the velocity of flow as very less? By regulating. This is the regulating valve actually. By regulating this valve, the velocity of flow in the tube is maintained as very less. When the velocity of flow is maintained very less, what we have seen, if I take this as the glass tube, right? If suppose you take this as the glass tube, how we found is the filament, whatever the dye filament here, which is entering into this is like a straight line. This is what we observed. Whereas the other parts, if I see, the other things are, this is all basically, if you see it, this is all the water basically, right? This is how it is. So whereas the color dye is seen, this is the color dye. Color dye, we can see clearly a straight line. What that straight line indicates, that means the color dye flowing straight means the fluid particles are moving in straight lines. Then the flow is classified as laminar flow. Then second point, what he has done, the velocity of flow is slowly increased. This is the second stage. This is first. So what is observed actually when it is done? Suppose you take, this is the pipe, right? When it is velocity of flow is increased, then what is observed is this is how, like, so that means the flow is also in this thing. The water flow is also like this. So this type of flow is called as basically it is wave like, right? The flow is like waves actually. It is what we call it as whatever the filament. This is the color dye. The color dye is in the form of a wave like motion, a wave like thing, then this is called as basically transition. And this type of situation is called as transition. And third one is the velocity of flow is increased, is further increased. Then what we observe actually, if I need it, so if I take it this as the pipe, right? What we have observed in the third one, whatever the flow it has come like that, then actually it is diffused. The color dye is diffused in the entire pipeline. So these are all color dye diffusion. So that means the color dye diffused. That means the fluid particles are mixing, right? And moving haphazardly. Hence, the flow is turbulent. Here, if you see it, the fluid particles are like this. They're also diffused actually, right? The fluid particles and the dye particles are all completely diffused in the pipe. Then we call this as basically this type of flow is called as turbulent flow, right? So now if you see it, from the first one, just if you go one minute back, so this is in straight line. So this is possible when Reynolds number is less than 2000. This is thing. Second thing, it is a wavy motion thing. That means Reynolds number is between 2000 to 4000. Right? Now the last one, this type of thing, which is we call it as turbulent flow, Reynolds number greater than 4000. This experiment is very really important. Here I have not taken fully into the experiment also, for the reason that exactly at 4000 are you going to get the turbulent flow. That means immediately after turbulent flow, after the Reynolds number crosses that, you get the turbulent flow. So this is all depends on under what circumstances you are conducting the experiments, your laboratory conditions, the way you are operating the valve actually, because the valve, a little bit change in the operation of valve, suddenly the flow may be changing from turbulent, from transition to turbulent. There are cases when you are conducting experiments straight away from laminar to turbulent also, without transition is also possible. So that's why for the present purpose you take it in this sense. Here what is important is first the moment Reynolds experiment is asked, explain the setup, experimental setup with a neat sketch, and then actually explain the three flows and then show the three figures. So total four figures, and whatever I covered before this, that means what is Reynolds number and how the for the five flow the Reynolds number values changes, that all you put, that all comes under basically this Reynolds the Reynolds experiment. So this completes the first part of or first question of your five flow. So in this lecture, I covered only one question. What it is Reynolds experiment, and what is Reynolds number? What do you understand by pipe flow? These are the things. But what is the concluding point of the for the entire this 30 minutes lecture is first thing is what is pipe flow? Only when the flow through a pipe or flow through a closed conduit which is generally circular is under pressure. Then at the same time pipe shall be running full, then only we call it as pipe flow. Right. Number two, basically, when flow is taking place through pipe, it is subjected to resistance because between the fluid particles and the boundary. And then naturally, why that resistance is there? This resistance is due to fluid viscosity. Right. Then next, so what is that resistance? How much will be that resistance? That we deal it afterwards. But one thing we are telling, when flow is taking place through a pipe, the flow is subjected to certain resistance. In order to overcome that resistance, certain energy has to be spent, certain energy is lost. Right? What is that energy that is lost? It depends on what is the type of flow, whether the flow is laminar or turbulent. Then next, how to know whether the flow is laminar or turbulent? So the only way is what is Reynolds number? Reynolds number is inertia force to viscous force. So then Reynolds number per pipe flow is rho Vd by mu or Vd by nu. So this is one thing I mentioned. Then what is Reynolds experiment? What are the figures of the Reynolds experiment that I explained? So with this, I will stop the lecture here and take up again the next lecture. Thank you very much.
Like, share, and subscribe. Hit the bell icon for more updates.